All right, so we're going to go through a few different examples here to show you how to do this counting rule in order to determine your total degrees of freedom so that you can determine whether your model is over, just, or under identified through the counting rule. So we're going to take each of these models one at a time. First, we determine the total number of observations. And in order to do that, you follow that formula of p times p plus 1 divided by 2. In this case, we have 4 variables. In this model, we are looking at how parental warmth and parent-child conflict impacts or is associated with adolescent alcohol use and how adolescent depression mediates that relationship. So we have 4 variables, and if we take 4 times 4 plus 1, which is 5, so 4 times 5 equals 20, divided by 2 is 10. So we have a total of 10 observations. And that's going to give us our total evaluation. We need to subtract that subtract from that our total number of parameters. So first, we're going to total up the total number of variances. And in order to figure out how many variances we have, we just look up at our model and we add up our total number of exogenous variables, so 1, 2, and our total number of residuals, or our total number of disturbances, or error terms. So we have 1, 2 of those. So we have a total of 1, 2, 3, 4 variances. The next thing that we're going to evaluate is the total number of covariances. So how many correlations do we have in this model? And here we have 1. So we have 1 total covariance. And then next we need to evaluate how many direct effects. So that's going to be our single-headed arrows, not including those from our disturbances. So in this model we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 total direct effects. And then determine our degrees of freedom. We add up our total parameters. So 4 plus 1 plus 5 gives us 10. So in this model, in this case, we have a total of 10 parameters. And if we take 10 minus 10, so take 10 minus 10, we get a big fat 0. So in this model, we are just identified with no degrees of freedom. Now in this next example, we are looking at parental warmth, parent-child conflict, and parental engagement, and how those 3 variables impact adolescent alcohol use and adolescent civil violations, and how adolescent depression and adolescent anxiety mediate those relationships. So the first thing we're going to do is, again, determine our total number of observations. So we have 1, 2, 3, 4, 5, 6, 7 total variables. 7 times 7 plus 1, so 7 times 8 is 56, and then divide that by 2, and we get 28, if I did my math right. So 28 total parameters. The next thing we need to do is to determine our total number of, 28 is our total number of observations. So we now have 28 observations. The next thing we need to do is determine our total number of parameters. So first is total number of variances. So we are going to total up our exogenous variables and each of our disturbances. So here we have 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. So we have 7 total variances. And then we need to total up our total number of covariances. So that's our total number of correlations we have in our model. And in this one, we have 1, 2, 3 correlations, 4. So 1, 2, 3, 4 total correlations because we have a correlation between 2 disturbances, 2 error terms. And the next is our total direct effects. So it's going to be our single-headed arrows, not including those from disturbances. So in this model, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total direct effects. And then we're going to total this up here. And so we get 7 plus 4 is 11, plus 8 is 19. So 19, or 28 minus 19, that gives us, what is that? 9. There we go. So we have 9 total degrees of freedom for this model, which means that we are now over-identified because we have a positive number of degrees of freedom. So this model is good because we are over-identified. This next model looks at the same model we had, but with more parameters in here. You can see we have much more. This is much more of a true mediation because we have the direct effects going from at least 2 of our exogenous variables. We're missing the direct effects from parent-child conflict on our outcome variables on this model, but you can see we have a lot more parameters. So we're going to have the same number of observations, so 7 times 8, 56 divided by 2 gives us 28. So we're still going to have 28 parameters, or 28 observations. And then we need to total up our total number of variances, and that should be the same, where we have 1, 2, 3, 4, 5, 6, 7 total variances. And then our total number of covariances, so that's going to be our correlation terms in the model. And we have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5 total covariances. And then our total number of direct effects. Again, that's our single-headed arrow, not including our residuals. So in this model, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have total of 12 direct effects. So if we add these up, that gives us 7 plus 5 is 12, plus 12 is 24. So it's really hard writing with your right hand with a mouse when you're left-handed. So 28 minus 4 gives us 4. So we are still over-identified with 4 degrees of freedom in this model, which is much more complex than the last one. In this model, I'm going to give you an example of an under-identified model. You can already tell looking at this model, you should be able to see that we did not follow the rules of specification. This is a non-recursive model where we have arrows going all sorts of which ways, and we have lots of different kinds of circles within our model. But for the purposes of this example, I drew this out so we can see what an under-identified model looks like. So we're going to first determine our number of observations. We have 4 variables. 4 times 5 is 20, divided by 2 is 10. So we have 10 total observations. And then the next thing we're going to do is count our total variances. So we have 1, 2 exogenous variables, and 2 residuals or error terms, which gives us a total of 4 variances. And then our covariances, we're going to add up our double-headed arrows, so our correlations in here. And here we just have one covariance in our model. And then lastly, we're going to total up our direct effects. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 total direct effects. And if we take up our parameters and add them together, 4 plus 1 is 5, plus 10 is 15. 10 minus 5 gives us negative 5. So now we have negative degrees of freedom, which means that our model is under-identified. There are too many parameters for the observations. And we're in that place of where the first example I gave, where we have a plus b equals 6. So we have many possible parameters that could fit a and b that still fits our observation of 6. So the model in M+, this would not be able to be ran because M+ would not be able to determine an estimate that works for each of these parameters because there are many possible answers. So what you will get is an error in M+ that tells you the model may not be identified. In some cases, it will still run the model and give you estimates. But if you run it again and again and again, you will get different estimates because of that under-identification issue. Even if it does run, it will still tell you, warning, the model may not be identified. Examine your model. you will be able to determine, looking at the output in M+, how many degrees of freedom your model does have. That's going to be in the model fit indices that we'll go over next week when we cover estimation. So even if you don't evaluate it ahead of time, you will still be able to know how many degrees of freedom your model has by looking at your output. But evaluating this is important so you don't run into that issue later on, and so that you can understand how identification works and how you evaluate identification. So in this last example, I wanted to show you an example of a CFA, and also where we have some constrained parameters to show you how to total up and figure out your degrees of freedom when you have latent variables and when you have constrained parameters. So the first thing we're going to do in this model is we're going to look at our total number of observations. So again, we're going to total up our manifest variables. We're not going to include our latent variables because these are not observed variables. So we have relationship trust, relationship satisfaction, 1, 2, and then each of the indicators for our latent variable. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total variables. 8 times 9 is 72. Divided by 6 gives us 36, if I did my math right. So we have 36 total observations. And then what we need to do is figure out how many variances we have. So our variances, again, is going to be our exogenous variables, 1, 2, and then each of our disturbances, 3, 4, 5, 6, 7, 8, and then each of our latent variables has a disturbance with it too, 9, 10. So we have 10 total variances, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total variances. The next thing we're going to do is total up our total number of covariances. So our total number of covariances is going to be our double-headed arrows, our correlations in here. So we have 1, 2 of those because we have the error terms between our latent variables correlated with each other here. And then lastly, we need to evaluate our direct effects. So you'll notice here we have a 1 written by 2 of our direct effects. These two are constrained, these two paths are constrained to be 1. This is one way you can create a scale for your latent variables. We're going to go over, when we cover confirmatory factor analyses, multiple ways that you can create scales for your latent variables, because that's a necessary thing you have to do in a CFA. So because these two are constrained to be 1, they're constrained parameters, we do not count them towards our total number of parameters. We only count freely estimated parameters. This would be the same whether if a variance was constrained to be a certain value, or a correlation or covariance was constrained to be a certain value, you would not count them. So in this case, when we total up our total number of direct effects, we are not going to count up those two paths that have the 1 next to them. So when we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total direct effects. Again, we're not including the arrows coming from our residuals or any constrained parameters. So when we total these all up together, 10 plus 2 is 12, plus 8 is 20. So we have 20 total parameters and 36 observations. So 36 minus 20 is 16. So we have a total of 16 degrees of freedom in this model. So this model is over-identified. We're good to go on this model. So this has shown you several different examples of how to determine degrees of freedom through a variety of models, and I've showed you examples of under-identified, just identified, and over-identified, including an example of how you would do this with latent variables in your model and having constrained parameters. So on your lab, you will need to be able to evaluate and determine the total number of degrees of freedom and whether that model is over-identified, just identified, or under-identified. The second part around the rules of identification are for the measurement model. So for the CFA part of your model, the latent structure of your model. For this, there are 2 rules. First, each latent variable must have a scale set to it. So we're going to go over this when we cover confirmatory factor analysis. You will not be able to do a CFA without having a scale set to it, so that'll be taken care of when you conduct your CFA correctly. Rule number 2 is that each latent variable in the CFA must have at least 3 indicators whose error terms are uncorrelated with each other. So you can have some error terms, some disturbances that are correlated with each other in your CFA. However, at least 3 of them need to be uncorrelated with each other. And also, you need to have at least 3 indicators, period, in your CFA. If you have fewer than 3, so if you have 2 indicators, it's not possible to have 1, but you can have 2. If you have 2, there are a lot of additional complex rules to make sure that it is identified. We're not going to get into that in this lecture because that gets into a little bit more complex pieces than we need to cover for the purposes of this class. If you are, for your paper, doing a latent factor with 2 indicators, come talk to me. But it would be better to make sure you have at least 3 indicators. So that covers this lecture on identification. I've shown you how to determine your degrees of freedom to know whether your model is over, just, or under-identified. And keep in mind that if your model is under-identified, M+ will scream out to you with an error and say the model may not be identified. Check your model. It may still give you an estimation, depending on the severity of the under-identification if you do have that issue. But it will give you that error term and say the model may not be identified. Check your model. It may give you additional information after that sentence telling you where the problem is. So it may say, for example, the problem involving parameter 32. So it will try and tell you where it seems to be a problem with identification. But if you have that issue, then when you can go back to your model and determine your total degrees of freedom and figure that out. Next, we're going to cover model estimation. So we're going to talk about how to run it in M+, and how to read the output in M+, from your model fit to your actual path coefficients estimates. So that's what we're going to cover next week.